I'm going to introduce Josie, who is our resident expert for the day. She's a sustainability manager on the ESG and carbon team at WAP Sustainability, which is a full service sustainability consulting firm. She has worked with many industries across the board, worked with national home builders, steel, tile, chemical manufacturers, global retailers, amongst others. So she's very well versed in the measurement and disclosure of greenhouse gas emissions across industries. So she builds long-term relationships with her clients and helps them to understand and manage their emissions on an ongoing basis. So we're in excellent hands today. I'm going to hand it over to Josie. I'm going to mute my microphone and yeah, take it away, Josie.
Great. Thanks so much, Wendy. Hi, everyone. Welcome. I'm excited to be here today. So I'll be presenting on an introduction to climate and carbon. And as Wendy mentioned, I'll kind of run through the content here in the slides, and then at the very end can open it up for a Q&A session for any questions that you may have. So next slide. This presentation is aimed at helping you to understand kind of how we define climate, the impacts of our changing climate, what we're seeing for the US and international response from those changes, and why and how you can start reporting on and working to reduce your carbon impact. So to understand climate, let's begin by looking at the kind of various terms that are consistently thrown out. So on the next slide, all of these terms kind of come up when you hear about climate. So is climate weather? Is it carbon emissions? Is it global warming? Are they all climate? What do they all mean? Do they all mean the same thing? So to kind of further define each of these, let's get into it on the next slide. So first, kind of at the most basic level, we need to understand the difference between weather versus climate. And so weather is what we experience on a day-to-day basis. It's sunshine, rain, snow. It can be hot summers, cooler winters, and storms. And this fluctuates with the seasons and varies naturally kind of from one year to the next. Meanwhile, climate refers to the average weather experienced over a longer period of time, typically defined around 30 years. And how this is measured is by temperature averages over that period of time, over those 30 years, for a given region, a country, or even on a global basis. And so when people say climate change, they are referring to how much our climate is changing over time. And so how this is calculated or thought about is scientists are using a combination of climate models, as well as land, air, sea, and kind of space-based observations to research how extremely weather events are changing over time. So as we all know, the US is a very large landmass, and we have very different seasonal temperatures across the US that can swing from 115 degrees Fahrenheit to well below -15. So we see a wide range very consistently. But since the 1970s, the US has continued to warm. And about 9 of the 10 warmest years on record have occurred since 1998, with 2023 and 2024 being 2 of the warmest years on record in the US. So to explain what's happening and what is causing this, we need to first look at the greenhouse effect. And so the greenhouse effect it's a natural phenomenon, and it is what makes our planet livable. So it occurs in the Earth's atmosphere and essentially makes it warm enough for us to live here. So without it, the Earth would be way too cold for life to exist here. And how the greenhouse effect works is that the sun's radiation comes down through our atmosphere and warms up the Earth's surface. And then as the surface heats up, it radiates some of that heat back up into the atmosphere. And when that heat escapes back into the atmosphere, it is often absorbed by gases in the atmosphere, such as methane and carbon dioxide. And those gases, which absorb the heat, trap that heat. And so when they trap that heat, they also release some of the heat energy back down towards Earth, which keeps the temperature of our Earth high enough to be comfortable for life. So you'll see with the arrows, it's kind of this exchange of the sun's heat coming down. Some of that heat is absorbed, some of it's reflected back up and trapped by gases, and then that heat energy is then released back down to the Earth's surface. And so this is a natural process that makes Earth livable. So these greenhouse gases that are absorbing the heat, they exist in the atmosphere for a long, long time. It could be decades, even up to centuries. And they're called greenhouse gases because they trap the heat near the Earth's surface, similar to how a greenhouse would trap the heat from sun's rays in order to help plants thrive and grow. So when the concentration of these gases increases, it leads to more heat energy being trapped. So more greenhouse gases, more heat being trapped. And so these increases of greenhouse gases, of the concentration of them, those do occur through natural processes such as volcanic eruptions and on a kind of large geological time scale of millions of years from slight changes to the Earth's orbit. So there are natural processes that contribute to this increase in the concentration of greenhouse gases. And those in turn lead to long-term natural changes to the climate. However, on the next slide, scientific communities around the world are agreeing that it is predominantly human activities that are leading to this net gain in greenhouse gases or carbon dioxide, kind of over and above what would already be occurring through the natural processes. So the concentration of greenhouse gases in our atmosphere, which is contributing to the greenhouse effect, is increasing at a rate, higher than what it would be because of human activities. And so this in turn leads to what we know as global warming. So that means that the planet's average surface temperature is rising. And this has been measured and has been shown to be at a rate that's quicker than from what's occurring naturally. And as a consequence of that, that's why we are now seeing human-caused or human-induced changes to our climate. And so this warming planet kind of disrupts climate patterns. It leads to really weird, kind of more extreme and unpredictable weather, including both hotter and colder temperatures. But while some regions may be kind of experiencing this extreme cold in some instances, the long-term trend that we're seeing is a warming planet, which is why global warming is the correct term here. And the key detail to understand with all of this is that all of this warming and the concentration of greenhouse gases is happening in a really compressed time frame. So a lot of the natural processes that occur on Earth, that they're operating kind of on this geological time scale. But the increase in greenhouse gases, largely due to human activity, is happening in a really compressed time frame. And so the changes that we're seeing right now are happening very quickly and have the potential to, cause great impact kind of on all living things on Earth. So next slide, looking a bit at how carbon is produced and how it exists in the atmosphere. So similar to the greenhouse effect, there is a natural process called the carbon cycle, which is the release and the absorbing of carbon. And so carbon through this cycle is emitted and taken up by a wide variety of sources, kind of shown in this diagram. You can see the arrows kind of circling here for a number of different processes. And there are two distinct parts to it. So there are exchanges of carbon dioxide where things like plants and trees and oceans are emitting and absorbing carbon dioxide on a continual and really quick basis, often hour by hour. And then there are kind of large carbon sinks that are decomposed plant and animal matter, and those take millions of years to form these really carbon-rich deposits. And those deposits are then extracted and refined, and they create fossil fuels. So also within this cycle, there are two key areas of carbon emissions that are caused by humans or linked to human activity. So those are above and beyond what nature produces, and they have been steadily increasing since the Industrial Revolution, since we have started kind of manufacturing more and emitting more. And first is the extraction and burning of fossil fuels, and those fossil fuels are used to produce electricity, power our vehicles, and fuel industrial processes, such as the manufacturing of construction materials and other goods. And then the second part of kind of this human-caused carbon emissions piece is deforestation and land use change. So land use change compounds this problem because it's the practice of changing natural landscapes to either agricultural land or kind of a built environment, which directly causes additional emissions because we are reducing the capacity for a carbon sink. So I think one example here would be wood. Obviously, wood is a fantastic resource. We need it for a number of different things, but in order to get that wood, we are cutting trees, and the cutting of those trees is just removing another carbon sink from this cycle. And so that's where we're getting a bit of an imbalance, and carbon dioxide or carbon concentrations in the atmosphere are starting to increase. So here on the next slide, it's not just carbon dioxide that is causing changes to our climate. There are many other gases that we produce that are also increasing the ability of our atmosphere to trap heat. And compared to carbon dioxide, these gases here have a far greater warming effect, pound for pound. And that is based on how long they exist in the atmosphere, their lifetimes, and kind of a number of other qualities. So the first gas here is methane, or CH4, and that is produced by grazing animals such as cows and sheep. So it can also be produced in kind of the anaerobic decomposition of plant matter, so in the absence of oxygen, but primarily it's from cows and sheep and these grazing animals on agricultural land. So methane is an incredibly potent greenhouse gas. It's roughly 25 times more potent than carbon dioxide because it has a lifetime of about 9 years compared to carbon dioxide's hundreds of years. So that means 1 metric ton of methane has the same impact on warming the Earth's atmosphere as about 25 metric tons of carbon dioxide. So pretty interesting when you get that comparison. It's much more potent. The next gas is nitrous oxide, or N2O. And it's more commonly known as laughing gas, but it has a lot of other applications, including as a propellant gas. So that will create products like canned whipped cream, but it's also used in a number of fertilizers. So this is a non-toxic, non-flammable gas. Obviously has a lot of applications in our world, but it's almost 300 times as potent as carbon dioxide. And then we have sulfur hexafluoride, or SF6, and this is a chemical that has really helpful insulating properties. So it's kind of perfectly suited to high voltage switchgear. It's used in a lot of kind of high voltage electrical equipment, specifically because it's non-flammable, non-toxic, non-conducting. But a leak of just 1 kilogram of this gas is comparable to releasing about 23 tons of carbon dioxide into the air. So again, really potent. And then finally, just want to highlight 2 groups of chemicals that are used really widely in the kind of heating and cooling space, such as refrigerants. And these are perfluorocarbons, PFCs, and hydrofluorocarbons, HFCs. So again, very, very potent, but have a wide range of applications in air conditioning units and being used as refrigerants. So with the HFCs and PFCs alone, in the US, these gases account for about 3% of our national greenhouse gas emissions, which is pretty interesting. So I think when considering all of these gases, it's kind of funny because I think typically we'll hear thinking about global warming, well, oh, we just have to eat less meat. It's a lot of this can be attributed to cows and the methane that they are producing from, the land use change to agricultural land, as well as kind of the methane that cows naturally emit. So I want to call that out as while cows may contribute a fair amount of methane, which is considered a really potent gas, that's not really the core of the issue here. It's cows combined with everything else highlighted on this slide, like the air conditioning, it's burning coal, it's driving cars. So it's all of these kind of human-caused activities that are contributing to increased emissions. And so while there are multiple greenhouse gases, as we've chatted about here, carbon dioxide accounts for the largest amount of greenhouse emissions from human activity. And so because of that, it's really used as the best measure of climate. So just to recap here, as I explained earlier, our climate does change naturally from kind of slight changes to the Earth's orbit or our tilt. And that kind of increase or the tilt towards the sun. But again, we have these increased concentrations of greenhouse gases that are due to human activity, which are causing the Earth's surface temperature to steadily increase, which is enhancing the greenhouse effect and in turn contributing to much more extreme and unpredictable weather, and which over time is causing changes to Earth's climate or our long-term weather patterns. So there are a number of things that have kind of occurred through this process already, since we're seeing gradual warming since at least the 1970s. Even if we were to stop emitting tomorrow, there are kind of some significant changes that have already occurred to our climate, with ice caps melting, ocean temperatures increasing, causing sea level rise. Permafrost is melting, which is a critical carbon sink, and also houses, a lot of methane. So we're just kind of seeing some exacerbated effects through this cycle. So for kind of the next portion of the presentation, with our climate changing, and now we understand kind of how that is happening, I want to go into some of the tangible impacts that we are starting to see. So as the concentrations of carbon dioxide and these other greenhouse gases are increasing in the atmosphere, we're getting warmer periods, and that's the greenhouse effect. Conversely, at lower concentrations of CO2, we get cooler periods, which are ice ages. And the last ice age ended about 12,000 years ago. So since the last ice age, the concentration of carbon dioxide has gone up and up and up, coinciding with the emergence of agriculture and society. So as the right hand of this graph shows, the concentration is now continuing to rise at a significant rate way beyond what we've seen as the usual kind of natural fluctuation or the natural cycle over the last few 100,000 years. And you may be wondering, when looking at this graph, how we even know what was happening in 600 or 800,000 BCE, and what the concentration was back then. So ice cores provide really helpful historical data for those time periods. It's almost like a kind of point in time data that's stored in the ice. And so that's how we're able to see this natural trend of increases and decreases in CO2 concentration, in comparison to more recent times where the increase is more significant. So, as the data shows, this increase in CO2 concentration and surface temperature really correlates with the Industrial Revolution, when the rate of burning fossil fuels just started to rapidly increase. And so then again, when overlaid with data on global average surface temperatures, this is where there is strong evidence, and we can really see that it is human-induced global warming that are causing kind of these resulting changes to the climate. So average temperatures have risen much more quickly since the late 1970s. 9 of the 10 warmest years on record in the US have occurred since 1998. Just for some more metrics here to show this increase, this past January 2025 ranked as the warmest January in the 176-year global climate record. And this broke the previous record, which was last year, January of 2024. So scale and rate of these recent changes really is unprecedented. And the key indicators, just want to hit this home, the key indicators telling us this are the global surface temperature and carbon dioxide levels or concentrations. So further emissions will cause further warming, and in order to stabilize warming, that will require reducing emissions of carbon dioxide. But as of right now, this trend isn't really showing many signs of slowing down. Next slide. So as we're seeing, there's evidence of these impacts kind of in the ever-increasing news reports of weather events that are playing out across the world and in the US. So we're seeing more frequent and extreme hurricanes and cyclones, wildfires, extreme periods of drought, also extreme flooding. And these are all leading to loss of life, property, biodiversity, and are really having longer term impacts on the way that people live and work. So these 3 photos alone are from the US in the last year, with hurricanes in Florida, LA wildfires, and then severe flooding in Vermont. And the impacts of these extreme weather events are really, we're starting to see the costs. So the federal government, it costs the federal government around $150 billion each year to recover from these events. So as the climate continues to warm, these storms will be more destructive and just more costly to recover from. The US in 2024 saw 27 weather and climate disasters, and each of those cost at least $1 billion in damages. So in response to this cost, this is all really heavily impacting the insurance market. So homeowners are experiencing decreases in the availability of coverage and then increases in premiums in states like California and Florida, kind of in response to the frequency of these extreme weather events. And so more widely, in addition to these weather events, the global warming is causing increased ocean temperatures. And with those increases in ocean temperatures, that means rising sea levels as the warmer water expands, which is also contributing to the bleaching of coral reefs and the killing of rare and important biodiversity. So we're seeing extreme impacts on a number of levels, and it's really starting to hit financially. So we know what greenhouse gases exist in the atmosphere. We know kind of their varying levels of potency and their impacts. But looking more closely at the sectors that are higher emitting really allows us to pinpoint where we can prioritize mitigation and reduction. So globally, the energy sector contributes most to our kind of worldwide emissions numbers, specifically energy used in industry and buildings. And then as we can see here, the US is matching that trend with electric power being or transportation being the top, followed by electric power, industry, and then residential and commercial. So to kind of get a bit deeper into each of these sectors, starting out with industry, um, this is the uh, third largest contributor to US emissions. And on the next slide, um, I have a few examples of just what industry means. So this essentially covers the production of the goods and the raw materials that we use every day. So all of these goods are really necessary for what we do. And this encompasses the manufacturing of, critical building materials like iron, steel, concrete, um, as well as wood products and the impacts associated with construction. Meanwhile, for the residential and commercial sectors, um, these emissions can be attributed to kind of everything within buildings that are consuming energy. So it's the emissions associated with heating and cooling buildings, as well as all of the appliances within buildings that are consuming energy to operate. So naturally, because of that, energy usage in buildings can be correlated with weather conditions. So if one summer is much, much hotter or warmer temperatures extend kind of longer than is what we consider typical, then the emissions will be increased in order to run those air conditioning units to kind of match those weather patterns. So further drilling down into the emissions associated with buildings, there are two ways that we can think about carbon in buildings. And the first is embodied carbon, and the second is operational carbon. So for embodied carbon, that is looking at the impacts from the manufacturing, the transportation, the installation of all building materials, all components that are going into a building. So think about everything from the concrete to the cabinets to the carpet. Each of those components carries a footprint and combined contributes to the embodied carbon of the entire building. Meanwhile, operational carbon looks at the emissions associated with the building's energy consumption. So it's for one building, the annual electricity or natural gas consumed. I think one kind of tangible example of this distinction would be the laptop that I'm working on today. So it takes a lot of embodied carbon to make the laptop, but as soon as I plug it in to charge it, that's when the emissions become operational carbon. And over the lifetime of this laptop, the impacts from operational carbon tend to outweigh the impacts from the embodied carbon or the production of this good. So when thinking about embodied versus operational, it's essentially emissions from making the good versus emissions from fueling or using the good. And I think just want to call out here that when considering both of these, the building sector has done a great job on addressing operational carbon to date because it directly impacts your costs. So if you have bad windows, it's more expensive to heat the building. But efficiency upgrades like replacing the windows to kind of mitigate the heating and cooling costs, that directly impacts your operational carbon as well. So now that we have an understanding of the data and where emissions are coming from kind of within the US, what are we doing about it? And so we are seeing response on a global, national, and local level. And so just want to get into the regulatory response to climate. So first off, starting with data, the regulatory response is largely informed by the emissions data and the trends that we are seeing. And so one of the main sources of this data is the Intergovernmental Panel on Climate Change, or the IPCC. And this is an international group of scientists. The group was formed in the late 80s, and they assess climate change and provide regular assessments, which then inform governments and in turn policymakers. And it's also an additional very helpful resource for global climate negotiations. So these IPCC assessments outline the scientific knowledge of climate, looking at the past, the present, the future, the impacts of climate, and then the future options for adaptation and mitigation. So the IPCC's most recent report, the sixth assessment report, was released in 2021. And this report really clearly outlined the trends that we just talked about, that the human-caused rise in greenhouse gases has increased the frequency and intensity of extreme weather events. So looking at this graph, if you've heard we need to limit warming by 1.5 or 2 degrees, this graph kind of demonstrates or speaks to that and explains the various potential scenarios following those trends. And so the world is responding to this data kind of in a number of ways. So first, starting out on the international level from a regulatory standpoint. In 2015, 2016, the world concluded the Paris Agreement, and it was the first global climate change agreement. So it was kind of a major development in really concerted action against the impacts of our changing climate on the world stage. So what the Paris Agreement set out to do was to develop a global framework for avoiding the most damaging effects of our changing climate by limiting global warming to well below 2 degrees Celsius above pre-industrial levels, as well as pursuing efforts to limit warming further to 1.5 degrees Celsius to avoid the worst effects of the changing climate. And then for the EU, we're also seeing increased regulation with two different items. The first being the Corporate Sustainability Reporting Directive, or CSRD, which is requiring companies to disclose a number of sustainability and risk metrics, kind of impacts, risks, and opportunities, which does encompass greenhouse gas emissions. And then the second in the EU that I want to focus on is the Carbon Border Adjustment Mechanism, or CBAM. And this is essentially almost a carbon tax without being called a carbon tax, because it's targeting how much carbon is being imported into the EU for certain materials like iron and steel. So on the international level, these are very comprehensive requirements that companies are just starting to disclose on. I think moving to the national level, more recently in the last few years, we have seen some of the largest action occur kind of with the Inflation Reduction Act in 2022. So the IRA was incredibly comprehensive and provided a lot of opportunity for funding, mostly kind of throughout the country, for a number of different projects like energy infrastructure and low embodied carbon materials. So currently, kind of the status of the IRA and the BIL is that they are under review, and any funds that had not already been dispersed are under review. So I think here, just to call out, obviously our US government changes every 4 or 8 years. And the trend that we are currently seeing with the new administration is very similar to what happened previously, beginning in 2016. So when this administration was in power last time, we saw a large transition from federal to state or local. And we are, again, seeing the same. So I want to get into the state level regulations that you could be impacted by, both on the operational and embodied carbon fronts. So on the left-hand side here for operational carbon, these initiatives are impacting companies of a certain size. So kind of how this is defined for most of these bills is that it is companies doing business in these states with annual revenues over 1 billion. And for operational carbon, that's at the company level. California being the signed bill at the top here, with 4 other states following California's lead with these proposals. Meanwhile, on the right side with the California bill, that is targeting embodied carbon reduction of building materials for all new construction. So with AB 2446, it is aiming to set an embodied carbon baseline by 2035 or by 2026, with reductions of 20% by 2030 and 40% by 2035 against that 2026 baseline. The Colorado bill is slightly different in that it is incentivizing kind of the use, the purchase, procurement of low carbon building materials, because those materials are, through this bill, exempt from state sales and use tax. And then lastly, the New York bill, this is requiring global warming potential limits for concrete mixes used on state construction projects. So kind of getting down to the next level on the next slide, we're also seeing a number of initiatives at the local level requiring use of construction materials that fall within certain GWP limits or global warming potential. So we're seeing kind of cities and counties around the US with multiple initiatives. Each of the kind of points on the map here is a different initiative with just a few called out on the side here. So throwing out GWP limits, global warming potential, I'm sure, and a number of these kind of state and local regulations, I'm sure this raises a number of questions like, how do I comply? What is GWP, etc. So I'd like to just quickly get into the basics of emissions measurement and some opportunities for reduction in order to comply with everything I just outlined. So the measurement of greenhouse gases is a really critical piece to complying with all of the regulations that I just mentioned, whether it's at the company or product level. And this practice is often called carbon accounting. So instead of regular accountants looking at dollars, we are measuring carbon, or more specifically, carbon emissions. So thinking back to all of the greenhouse gases that we learned about earlier, the methane, the nitrous oxide, carbon dioxide, each of those exists for a different amount of time in the atmosphere. And so to convert the emissions of those gases onto kind of a level playing field, we convert to carbon dioxide equivalent using global warming potential factors. So using a common unit then allows us to equally compare the emissions of different products, facilities, and companies. The GWP factors are outlined by the IPCC reports, which I mentioned earlier, the 6th report having been released in 2021. And that most recent report tells us that 1 metric ton of emitted methane is the same as the emissions of roughly 30 metric tons of carbon dioxide. So that's kind of where we're getting our conversions from, is the IPCC report. So there are different GWP factors for different time horizons because each of these gases has a different lifetime. And typically, kind of the most commonly used metric here is the 100-year time period. That's kind of the most frequent time horizon used in carbon accounting. Just want to call out here also that there is a future webinar on carbon reporting and accounting where you can learn many more details about this practice and what goes into it. So the measurement of greenhouse gases rolls up in a few different ways. And this kind of gets back into the embodied and operational carbon. So when a company measures its footprint, that is a greenhouse gas inventory, calculated typically on an annual basis, whether that's calendar or fiscal year. And this accounts for the emissions from facilities, vehicles, company purchases throughout the year, the products that you produce, and kind of other categories throughout your supply chain, both upstream and downstream. And then life cycle assessments look at the emissions of one product and consider the raw materials, the manufacturing, the transportation of that product. So kind of emissions associated with the production of that product. So in addition to meeting the requirements or regulations that I've mentioned, both of these studies allow you to see kind of which areas are contributing the most emissions, or you can identify hotspots. That's kind of what we call a hotspotting exercise. So since emissions are so closely tied to energy usage, identifying hotspots through these two exercises can really identify areas for improved energy or operational efficiency and reduce energy use and cost in response along with emissions. So getting into the mitigation or the reduction aspect here, there are kind of two main ways to think about this for addressing the impacts of our changing climate, and those are mitigation and adaptation. Mitigation is really about reducing the amount of emissions that are in the atmosphere from human activity. So it's activities or kind of exercises that we can go through to just directly reduce emissions from what we're doing. And that typically is just using less fossil fuels to power buildings, machinery, vehicles, and equipment. So that could look like switching to renewable energy sources. It could look like electrifying your fleet, or reforesting deforested areas, and additionally using carbon capture and storage technologies. And then for adaptation, this is also sometimes referred to as resilience. So these are resilience measures in response to, our understanding that temperatures are rising, weather is becoming more extreme. These are measures that we can take to prepare for those changes. And that can look like the kind of altered design of buildings to counter rising sea levels and extreme weather, the increased frequency of storms, flood events, investing in materials that are kind of more resilient and can withstand more extreme temperature fluctuations. So I think in considering this slide, both mitigation and adaptation are necessary to consider kind of together. They're not mutually exclusive. We need both of these to come up with viable long-term solutions. So with kind of any decision, sustainability included, all risks and opportunities must be weighed for these long-term solutions. So when it comes to climate solutions, a holistic view really is key. Obviously, you need to ensure at the most basic level that you have a return on investment and that you are profitable and that your company is, able to experience longevity. So sustainability inherently kind of contributes to that return on investment because the aim really is to just put forth strategies for your products to last longer. So making a useful, durable product really is a sustainable concept. So it's all about the consideration of environmental as well as the economic consequences, the impact on your company and your customers. Everything needs to be considered for these long-term solutions. So to wrap up, hopefully this presentation has provided you with some good basics for kind of an understanding of climate, its impacts, the response efforts in the regulatory landscape, and some opportunities for reduction. So thank you so much. I will pass back to Wendy to close out and open for any questions.